Good morning, good evening, good afternoon, everyone. And I'm the host for the Epics Hour session today. My name is Pooja, and let me hand over to our speaker, Mr. Daniel, and he will introduce himself and take the session. Give your introduction, Daniel. Thank you.
Thank you, Pooja, and I'm happy to be the inaugural guest for your first Apex Hours. It's going to be the hundredth and thousandth of Apex Hour ever. Excellent format, and I'm happy to be back here and share my first findings on Dataweave in Apex, which is a new feature that is going to be available in beta from the Spring 23 release on. So you can try it out in your orgs either today or from a few weeks on. And I'll guide you a bit through my experience with it. A few words on me. My name is Daniel Stange. I'm a CTO for an SI partner in Germany, DAD Interaktiven. I'm from a tech background. I'm a technical architect and I'm a Salesforce MVP. I'm pretty much certified in Salesforce, and I'm starting my MuleSoft journey. Certifying as a MuleSoft developer, and working on a few other things. I'm happy if you connect with me on Twitter or on LinkedIn. These are my channels, so you can find me there. I technically accept invitations on LinkedIn whenever I feel it's not spam. So feel free to reach out and connect with me. That's how I use the social media channels here. My topic for today, or first off, some marketing for Apex Hours, something I really, really admire for quite a long time. Amit is doing a great job, and I'm happy to be the first speaker as he starts to grow the team. You can find all the sessions on Apex Hours, and you can find all the recordings on YouTube. Use a lot of them, use them. It's pretty cool, and it's amazing how much content Apex Hours has created over time. So, what I'm going to do, I'm going to talk about Dataweave and Apex. I found out that I wrote my title not exactly precise because I'm not talking on Dataweave as it is in MuleSoft, but I'm talking about how it comes to life in Apex. Going to guide you a bit on what it actually is, starting with the too long didn't read. So if you think you know all of the things, then just hear my opinions and then you can move on. Otherwise, I'll guide you through my learning experience and show you how what Dataweave actually is and how it works. Talk about how you can use it for text processing to avoid some common pitfalls in this kind of data, and try another few use cases and show you some performance metrics and go over into considerations how you can use it in your specific cases at work. So, Dataweave and Apex, what is the fuss all about? The big thing is whenever you transform data, you can now put it into just two lines of code, and it's basically the anatomy of Dataweave in Apex is define a new Dataweave script resource. You kind of initialize Dataweave with that, and then you use this resource to execute the Dataweave script. And this will basically run the transformation, and around that you will probably need some code to prepare the things that you want to put in the Dataweave, and some lines of code to do something with it. But basically, this is it. This is the big thing. Create a new data script resource and prepare it to be used, and then use the Dataweave resource to actually process some data. So you might say, nice. So should we run everything to Dataweave? The answer is certainly no. As you might have guessed, there are limits and considerations. The big one first, you can only have 50 Dataweave scripts in your org, which makes it pretty much focused on the most heavy transformations that you're going to have. And also, when you start it up, there's a hefty amount of CPU time that goes into initializing the Dataweave instance for you. So I'll show you a few figures on that. So, and also, you can't do things with all kinds of files, but only a limited ones. At the moment, there's no import for modules and mapping, so that you cannot reuse things that you wrote. You have to define everything in your Dataweave script, and can't import a lot of that of things as you might typically do when you are a MuleSoft Pro. First off, what's Dataweave as a high-level primer? Dataweave is a programming language. It is used proprietary to MuleSoft, so it is the language that they use in their product as an expression language, as a data transformation language. And under the hood, it's a functional programming language, which runs somewhere in a Java virtual machine, as all the Mule applications run in JVMs. The thing that makes it a bit unique and uncommon for us Apex programmers is that variables generally are immutable, and functions may act as something that can be declared almost everywhere, and functions can also be a variable. So the whole design of a function is basically to make things fully repeatable and always return the same input, the same output, given that you put or do the same things whenever you put comparable things in it. You can nest functions into each other by calling functions on functions, and so on and so on. It's pretty neat, it's pretty nifty, and it's not exactly the same way as it is in Apex. So I'm also still struggling a bit with doing things right in Dataweave. What is relevant to know is that Dataweave by nature is strongly typed, but it has has type inference. So if you put something in and don't say what it is most likely to understand what you're going to do. So the type doesn't have to be declared beforehand, but if you declare it, then this is then the typing is strict, and you have to explicitly transform types into each other. So if you say if you implicitly try to convert types, this is not going to work. If you want to change a type of a variable, like for example, turn a text into a date or a date back into text, you have to do it with a type conversion and enforce the types. The very interesting bit about for all of us who work typically with maps in Apex, for example, and key value pairs, is that the underlying type that MuleSoft uses in Dataweave allows duplicate keys in key value pairs. So if an object has a key that is this key doesn't have to be unique. There can be 2 or 3 or 4 addresses in this at the same level in the same collection. It doesn't really work like key value storage that you as you know it. That is because in a transformation, you might get duplicate values at some point in time, and some data formats like XML technically allow this. And to handle XML, you have to have a type that is able to handle this specific thing about the payload. So the most important thing to remember is, or the first thing to think about at the beginning is know the payload, so the data that's going to go in, and have an idea how Dataweave will understand this the thing that you put in, and how other duplicate keys, how will they appear in the transformation. That is something that is really important to know and to handle, because this is where Dataweave scripts are going to break or do unexpected things if you if you do it wrong at that point. So let me give you a primer on how it looks. Dataweave has a kind of declaration. This is the percent DW 2.0 that defines this script as a Dataweave 2.0 family script. Dataweave is currently at version number 2.4 something. Still, the differentiation in the source files is only Dataweave version 1, major version 2, or Dataweave major version 1. So we don't go count up to the minor versions like 2.1, 2.2 or so. Always declare 2.0 to have that style of file. Dataweave file or Dataweave script then has a header, which defines basically input and output variables. You can give it a name, or should give it a name, so that you can address the input and the output, but you don't have to declare it. It will be there and will be addressable in some ways. But if you want to have structure in your files, then do it. Also, the header is the place where you can define variables, and also this is where you can define named functions. You can also define functions on the fly, which makes the script itself a bit unreadable. So it's advisable to put your functions in the declaration part up. And then there's you see a group of 3 dashes, which separates the header from the body. And in the body, the actual script goes in there. And this is called the transformation. So let's see. We will see some of these in the next few minutes. Keep in mind there's a header and a body. The header is to define things. The body is to actually write instructions what to do. Here's some transformation that I just simply wrote. I didn't actually write it deeply, because I just defined an input and an output with a data type. So I defined 2 popular Harry Potter characters in JSON, and I simply said I want this to be a CSV file with a separator of a semicolon. And without declaring anything, Dataweave basically forced the payload that I wrote in JSON into a CSV file. So if you have nothing big to change about the way data is presented here, a blunt coercion of the type is already enough to transform the payload into something else. So it's a good idea when you try to transform something or to have an early success or quick success, to simply try and output the thing that you put in with a type definition, just by repeating the variable name for the payload that you put in. I wouldn't rely on that. Just as a demonstration, this thing works, but basically you should try a bit harder to create something really, really stable and working. How does Dataweave actually do this? They have a kind of it breaks down into something that reads the file, the reader, the transformation that's happening in the as a part in the processing, and there's a writer, and they assume basically that they communicate through each other in a type that is called application Dataweave. It's a Dataweave object built on top of a Java object, and if you don't tell the transformation anything, then this is how it flows. Now, in this example that I have here, I have something defined an input that is called that I will call payload, and it's coming as a JSON. And this line, or basically the first thing, what I write in the body, as said before, goes into the transformation. It will be processed there. It's basically the instruction what to do. Then there's the first line. And the first line informs the the place between the reader and the transformation, that this is going to be application JSON and not a Dataweave object. And same for the transition from transformation to reader. This goes at this place and informs it that it's going to be a CSV instead of a Dataweave object. Fairly simple. It's just a 3-step thing: read, transform, and write. Now we're getting closer to really trying it out. And the problem that I'm going to show this on a problem that we all know. When you get text, when you pass data from place A to place B, you typically you often do this in a form of text. Text can have kind of structure in it. It can come written as a kind of just as text, with this is what we call plain text, and you could also write it into an Excel spreadsheet. If you pass it as an Excel spreadsheet, the way to make it understandable for all kinds of systems is export it as a CSV file. And the difference between an Excel sheet as it is and a CSV file is that there's just one character that informs other systems that this here there's a cell that ends and the next cell is going to start. We call this semi-structured because the structure is not really enforced, as I will show you in a minute. You can bring more structure to text if you have apply something like XML or JSON on that. But again, this is just another set of conventions, and if you don't do it right, it all breaks down to a semi-structured form. So the big question is, hey, if I pass it around in a semi-structured form, is that not enough? What's the problem with that kind of thing? And why could probably a fixed width format be completely supreme in its way? The answer is a really fixed form, like the fixed width, has metadata around it that cannot be corrupted by the content of the data itself, whereas the CSV file could. And let's have a look at this example that has all the problems that we typically see in CSVs, because as you can see in line number 2, the text separator or the column separator is used in the cell itself. And if you try to divide this file by the commas, then it's very likely that you split after harder because there is a comma. Most clients don't, because there are quotes around the cell. But if you don't know this or can't exactly hit it, then it will split at the second comma. Then there could be also the quoting character be included in the cell. So if you want to type a quote character, CSV typically escapes this by the backslash here. And it could get even worse, because if you could have multiple lines in an Excel sheet in each cell, which adds a line break, and the line break is a very tough problem to pass if you don't exactly follow the quoting characters. And in this case here, it's even more terrible because there is no opening quoting character in line number 4. So it's almost impossible to get this right. So big issue, and this is where MuleSoft or where Dataweave language is really strong and helps you, is the content and the data itself can have the separators, the quoting and escaping characters as part of the data that they are going to try to get around. In Dataweave, you can define these characters. So you can say for German text CSVs, you can define the separator as a semicolon. You can define the quote and the escape parameters to define what these characters are. And line breaks are basically handled gracefully if you go with the standard settings. Let's look at how this goes. I'm going to go to a Dataweave playground first to show you how this works. For those of you who want to learn Dataweave, the playground is the place where you can really start. To try this out, I have created a CSV file with standard comma separated values, let's try it out and convert it. But first, here's a plain Dataweave that has nothing in it, and as you can see, the variable payload that I set to, let's see, this is the original payload. If this comes in as payload without any definition, we will see the plain Dataweave object that has an object, and the object is defined as at least having some encoding and a media type which is sensed as a JSON object. That is all that comes from the definition. So let's quickly fix this and say the input is a JSON, and the output should be a CSV. We will have a comma separated file. If you say this is going to be XML, then we have a message object that is phrasing this in the bringing the message in a message object. That's as it is. So CSV first. We take the first CSV file. The name is now CSV1, so we have to make some adjustment and say this is the first payload is called CSV1 and a CSV file, and to control the output we want to say it's a JSON and output the CSV1. Oh, damn, it destroyed the CSV1 file into something that happens in the play count at times, so bear with me. There it is. We have the payload C with 2 rows. The first line goes into the column headers, which turn the keys here. So we have John and Jane in the file, and then we can dig deeper and say, here's the. It completely destroyed my prepared files, but anyway, we go into the second thing. Second thing is a CSV file, but now we have a comma in the content. So how is it going to handle this? We will have a description, and the thing that happens now is that we get a fourth an unnamed column. That's expected because there is a comma, and the comma is interpreted as a separator. So we put this fix this by putting quotes around it, and you can see now in a fully compliant CSV file it's not going to break. So example 3. Now this is fixed, and we have a quoted quote here. Double complication. Let's go with CSV3. CSV3. And there we are. Everything's fine. And fourth example that I have is a file called CSV4, which has, holy cow, there is our new friend Friedel Feuermann, and he's a German, and he used Excel to export this with a German line separator, and suddenly all of this is completely destroyed. Friedel did a bad job for us, but we can quite easily fix this, as I said, with the separator defined as in the input, and now we read we read this file okay again. There is a mistake still. Friedel is separated with a comma, so we fix it quickly. So as you can see, this is it is fairly simple to move these things around. Let's take the examples to a comparison between Apex and Dataweave. So I created a simple page here that splits the text and then creates a table from it and gives us some performance metrics. Let's quickly do this, and you see it's not going exactly fast. That's but it creates the same results. It looks pretty much like this, and as you can see down here, Apex does the job significantly faster with almost no CPU time overhead, while Dataweave takes a lot of time. This is kind of expected. I tell you why in a minute, but let's focus on go to the second example, which is the fully compliant CSV file with separators in the cells. And let's do this here and wait for the results. And there's the expected break. If you simply use a nested split method, it's pretty much one of the things that you can do if you don't want to resort to really deep regular expressions or pattern matchings. Then this is going to happen. Apex is the simple method in Apex is not going to understand the separator character and is creating new cells where Dataweave browses through without any problems. Still, performance is on Dataweave's side, and that's it for now for showing the CSV splitting. What we saw, and take a note here, performance of the Dataweave seems to be significantly bad as compared to splitting at a simple character. Yes, it is. We saw initialization time from between 1,500 to 2,500 milliseconds, and we saw transformation running times of 500 to 1,500 milliseconds. But if we created raised the volume of the payload, we have almost next to none impact on the execution time. So this is basically all independent of the amount of data. I didn't show it yet, that this doesn't really hit, but you can trust me on that. Next, one other use case where Dataweave comes really handy is actually create payloads for web service integrations or deserialize payloads that come over through a web service, and often you will see lots of complicated formats. I created kind of fake formats that you could that could probably hit you when you integrate with web services on, for example, SAP. This thing, for example, has demands that the addresses that belong to the account don't appear in inline as it is in billing address also, but rather expect us to have use XML attributes to explain what type of the address this is. Also, we want to have an external key and the Salesforce ID both in the customer name as an attribute, And we can simply ask our Salesforce org to send the list of accounts, and it will now hit a web service, and the web service gets all accounts, transforms it to the desired format, adding the external ID and the actual record ID as an attribute into the name object or element, formatting the address according to the requirement, adding a type for each address, and using agnostic labels like street, postal code, city, country, instead of billing street, billing postal code, and so on. We can use the same script or a kind of turned around script of that to post new accounts to our system. Here's the updates that I'm going to make. Same kind of format. You see, I cheated a bit because I made the addresses inline so that the message is a bit easier to write. And also this thing works with the same performance impact that we saw. So you get the response a bit slower than expected, but you technically have to write very little code, and I'm going to show you what it is. This is basically the Dataweave script that writes the output. It creates the customers element, it creates the customer element inside it, and then it runs something that is typical for Dataweave as a programming language and as a functional language. It defines, we have this expression like payload goes in here, goes into the map function, and assigns the outcome of the map function to a variable that or an iterable that's the record, and this is getting assigned to the curly braces. The braces express that this is going to create an object, and the object has the name attribute, including a marker that writes the XML attributes, and the name key is filled with the record name. Record is basically coming in here, and then we traverse with the full stop into the object and get to the name key. And same goes on here, all the places. There's a static mapping that I make by just assigning the address attribute type the value built to, and that's basically all that I have to do to do the conversion. And again, if you go to the classes that I had to write for this, it's not the cleanest of codes, and it has some debug statements still in here to get the actual outcome of the thing fast. But as you can see, it's just, as I said in the beginning, it's the query that gets the things, and it's just the 2 lines of code that formats the things, and then it's another line of code that assigns the values that I get to the response of the web service. That's basically it. So it's debatable what we actually can achieve with that, and the trade-offs that we make. But there's no way to argue that this creates a much cleaner separation in the code units that we call, which otherwise would cost you a lot of Apex lines and also a lot of cluttered classes in your namespace. So let's go back into the slides and discuss what we found. So to wrap up, if you're completely fresh to Dataweave, here's the few things that you really have to know to get your first results. If you pass in a variable, you can, as you know, in Apex, can traverse into the object that you passed in with a dot. And there's a special meaning of a double dot that you can use for traversal. if there are lots, if you have a nested object and lots of them have a key that is name, for example, or street, the double dot will find any name element or any name key in the object, no matter where it is and how deeply it's nested. You can combine both of them with the a multi-instant matcher. So if you do a dot or double dot, it will find the very first instance that that it matches. If you do dot and asterisk, it will find many of these matches. In the output object, you can traverse with a colon if you want to. So, for example, write the root element and the first member with a kind of root colon member, and so on. And you can there's a destructor notation that's probably too much for the beginning, but if you write braces and brackets, then you'll destruct the original object that you passed in and create an object on the fly. Same goes if you use the angled braces, where you destroy the original object that you passed in and deconstruct it as an array in the on the fly. There is, as I already explained, a so-called infix notation. So if you have a function that takes two parameters, the first parameter can either be in the brackets after the function name, parameter 1, parameter 2, but you can also write it as parameter 1, function name, parameter 2, which make nice syntactic sugar if you phrase your functions as verbs, where you can say like we saw, payload map into record. That makes pretty nice readable code. For all the map functions and the iterator functions, there is something. There's an optional second parameter that you could put in the brackets, which gives you the index of where you stand. So if you want to have a specific a numbered list later on, then you can call the index as well. And if you don't know what exactly the keys will be, you can use dollars for what you get out of the parameters. So target, in the second to last line, what I call target, will also be available as under the dollar sign. Second variable, which is index, will then be in $, and so on. There are three of these magic and dynamic parameters. That's $, $, and $, $. So that's the bare minimum that you need to know somehow to get the first transformations running. Let's have a look at how it performs when you use it. For the things that I did, I created a file that has 10,000 rows. I made a typo here. It's not 1,000 rows, it's 10,000 rows. I ran a Dataweave transformation on that. First thing to happen, you remember the first line that I wrote, that's the blue line, is taken around 2,000 milliseconds each run that I started. And then it does the transformation. Remember the second line that I showed, where it says Dataweave results equals Dataweave script execute. This is the first time I executed it in the transaction. It forms the red line, and it takes significant amount of time. And it's not process time; it is CPU time. So the dangerous thing. Then I tried out what happens if you run the same transformation again with another payload. So it's not exactly the same. It cannot be cached. It's just the same transformation on a different payload on the same instance of the script. And as you can see, the amount of time it needed for that dropped by about 7/8, between 80 and 90% improvement in the performance. Then I tried the same thing in the same transaction to start a new Dataweave transformation and initialize a new script, pass another 10,000 records, again, typo in the up there, not 1,000 rows, but 10,000 rows in there, and run the same transformation again. And the interesting bits are the initialization of the script takes almost no time in this case. The blue line dropped from 2000 something to less than 100 milliseconds. The next thing that's interesting to see is you don't have the spike in the transformation itself. It all runs on almost the same baseline as in the second run of the first operation. See, the green line dropped to between 100 and 200 milliseconds, and now it is also around 100 milliseconds. And also the first iteration, the red line, dropped to the same level. So the overhead in CPU time seems to occur only once. The CPU time consumption, and I did 50 runs for the same thing to record the numbers on a scratch org, a pre-release scratch org. It decreased the initialization time from about 2,000 milliseconds to about 50 milliseconds. The transformation from the first run dropped from 900 milliseconds to a stable 150 to 120 milliseconds. So if you reuse the Dataweave in the same transaction again, then you will have a significant performance improvement, but you will have to invest about 3,000 milliseconds of your CPU time for the first execution of Dataweave in your transaction. And that's basically a bummer. The one-time overhead is certainly through something that you can probably imagine. I'm not in Salesforce, I'm not in their engineering, but the pointers that I got is that you can imagine it as if there was another virtual machine that has to be added to the execution context. Things get passed around, and this is needed to provide the Dataweave at the mule application context, probably that you then use. What you get for that is something that is really, really powerful in transforming things. So what I did is basically baby steps towards real transformation work. I didn't show any functions in the transformation. I didn't show any nested transformations. I didn't show double input and nested outputs and all the stuff that you could do. There is a lot that you can do. If you pass in 3 or 2 things, you could do a lookup like you do with the VLOOKUP function in Excel and so on. Everything can be done on the fly if you want to. What you also have is high volume capacity. So if there's more than just a few lines, this thing will perform evenly well. And you can save a lot of code and in your org. It's not a limit any longer for quite a long time now, but the lines of code that you have, especially when you start writing things like XML, is just hard to read and hard to understand to people who don't really know the way around in the org. So if you ask me where there are good use cases for that, except toying around and finding new things, one thing is you can afford only one big transformation per transaction because basically you run out of CPU time at a given time. It's in particular helpful if you want to have a complex payloads to either compose or decompose. So you're exposing a web service to SAP, and there's a lot of things in this for example, order record that you get, you can decompose it with a transformation into the Salesforce object at your liking. It's also helpful for formats that are very likely to produce errors when splitting them with plain Apex, or generate a lot of CPU overhead if you split them with pattern matching in regular expressions, for example. And also, the thing where I see it happening is wherever you need to have a formatter or a interpreter for formats that are really hard to parse if you have little information on the payload itself. So that is reading and writing of XMLs. Yes, you can use the auto-generated Apex from a WSDL. That is an alternative, but also for complex JSONs. Reading that typically requires you to write something like a JSON parser that helps you to cast the JSON elements to a type and so on, which yields a lot of code in your integrations. So these are basically use cases where you could apply Dataweave as some kind of transformation language that is aware of the things that it's getting, and helps you to bring them into Apex objects, for example. And the one thing that I didn't show you explicitly is that you can use Apex objects as an output format for your Dataweaves. The limitations at the moment are that when you try a cross-object traversal, like if you think of an order and you want to have the name of the account with it and the order line items with it as a subquery, if you send something in like that into a Dataweave transformation, you will receive a gag, an Salesforce exception. I didn't ask. I didn't try to let it get it traced down. But I assume this kind of nested object structures are not supported at the moment. There are limitations in the input types. The most interesting one would be Excel files, so that you can read Excel on the fly from uploaded files. The Afro format, I don't know. I've never seen such a thing before. And also plain text is not supported, which is kind of a pity, but because of the of very common old mainframe systems that drop these kind of fixed width document. Okay, but you can live with that. What you also have to live with, I assume it's not going to come ever, is including modules and mappings. So you can the Dataweave as a mule application in a mule application supports composition and modularization. That is unlikely that you can have it in your org, as you can only have 50 Dataweave scripts. If you break it down into 2 or 3 modules that you try to import, you run out of Dataweaves very, very fast. And I assume this has impacts in terms of how this additional whatever you call it, JVM system, whatever container is designed. I suppose we're not going to see it anytime soon. If you want to start, there is a Dataweave playground. You saw this when I started a bit messing around with the CSV files. What you can also do is install the Dataweave extensions. If we have some time left, yes, we do. I'll show you. Can you show you a bit of the quirks it currently still has, because it's still in beta. And if you want to read up on that, there are a lot of resources around. The most helpful one is the GitHub account of Salesforce's developer force, where there is a full set of examples for Dataweave and Apex, so you can simply clone this code. It is from the pilot, so handle it with a bit of care. The Dataweave playground doesn't support Apex as object or type support, So you have to design it with Dataweave objects as a source and output, and then do the last tweaks in your Dataweave script in VS Code. Documentation for Dataweave in Apex is quite rudimentary at the moment. It's just 3 pages, but you have extensive Dataweave reference on the MuleSoft side. And if you're interested in getting deeper into that, there is a code live on Dataweave that aired just recently. You can follow the code live channel from Salesforce on YouTube to see that. Okay, we're at the end with that. I'll just briefly switch back to VS Code to show you the Dataweave extension. Can create a new mapping with the Dataweave extension, which could look like that. This automatically should have automatically a preview. Doesn't do that at the office at the moment. There it is. And if you define an input, which we could say payload application, let's call it CSV hello world. As application CSV, we could define a sample pattern. The sample pattern could be hello Dataweave, and go back to my mapping and say this is the CSV hello world. This needs to be saved. Then we get a sample output. So it's fairly simple, fairly integrated. You can at all times jump back to the definition of the example file. You have the auto preview, so which makes it basically at feature parity with the Dataweave playground, and then you can use it. You can use it straight on your machines, fully aware of the object that you have in your project. One word about this: it won't deploy immediately because it writes metadata files that are in API version 53. If you define Dataweaves in API version 53, it won't deploy to any org in the public space, because Dataweave is only available in orgs from API version 56. So currently, because all of this being in beta and not really fully productive, you have to manually fix the definition to API version 56 to make it work at least. And with that, I had jumped back to the presentation. Thank you all for joining. Let's have a look at the questions. The first question is, if we add 1 million records in CSV, will it generate JSON for 1 million records? Technically, yes. If you return the 1 million records to Apex, you have to put it somewhere, which is the heap in your transaction, and the heap size for synchronous transactions is 6 megabytes. So if you put 1 million records in, it will read the 1 million records if you could hold it in memory, and the returns 1 million records in CSV in JSON, because it's just working everything as a batch, which is a bit different than in MuleSoft. If you run Dataweave in MuleSoft, you can process the 1 million records in streaming mode, which basically means one record or a batch of record going in, and it will run just as long as there are records coming, which makes it a bit less intense in memory usage than loading 1 million, transforming 1 million, passing back 1 million. So I didn't try if it would work, because I didn't upload a file that has 1 million records. Mine had 10,000. It worked quite well, but I didn't try 1 million, which is 10,000 times 100, 10 times 100 times more. So I didn't look at the memory footprint. I assume it wouldn't work, depending on what the file is looking like. Luke asked, the scripts were not easily. Oh yeah, the thing is, the Dataweave scripts that you can push to your to a Salesforce org cannot have any import statements. So if you define functions or so in a dedicated Dataweave script, for example, to act as a module, then it's currently not possible to import them in your transformation or in your new Dataweave script. So you could have an import because right at the moment, the thing is these mapping files cannot have this kind of import statement in here to load things that you created in a different file. That is basically a bit of a bummer. There's technically a few things that you can do with an import statement. You can load more of the standard Dataweave capabilities. So there's the Dataweave data DW namespace and DW core as the core library, DW crypto, the Dataweave crypto library, and so on. I didn't try this out for the core modules, but you can definitely not import custom modules and custom transformations in here. So breaking down your scripts into different files and then composing it for the needs that you like is currently not possible. And if it were, you'd have a hard time to break it down in pieces that fit the 50 scripts in your org. So it comes the problem comes from two ends. You don't have enough capacity to really modularize your scripts, and you also don't have the capability to compose the scripts. That's what I meant with a lack in reusability or lack of support for modular design. Okay, any more questions? If not, thank you. We're almost exactly at the hour. Thank you very much for joining. Feel free to connect and reach out. And back to you, Pooja. Thank you for hosting me.
Hi. Thank you, Danny. And there is a question in the chat window.
Yes, that's basically that's German. What Luke wrote wrote "Danke vielmals," which means "thank you very much." That's not exactly
Oh, okay.
it's,
Yeah.
I appreciate you speak my language. Thank you, Luke.
Thank you so much for the great session. And thank you very much. I mean, for taking care of this everything. First of all, I'll stop the recording.